Okay, I'm gonna move on. Polynomial function. We wrote this out last chapter about rational functions and people freaked out, so I thought I would write it myself this time. A polynomial function, there's certain things that a polynomial function can't have. It can't have crazy things in the exponent, so it can't have a negative exponent, it can't have fractional exponent, it can't, which includes like radicals and all that stuff. And so normally when we write a polynomial function, I'm just going to say p of x. We normally start with the highest degree and we work our way down. So if I'm writing like a general form, I could say a sub n, x to the n, where a is just leading coefficient, plus a sub n minus 1, x to the n minus 1. I know it's scary, right? And I'm just going to do plus dot dot dot
Plus
a sub 0. Let's just do that. No, that's
I think that's a sub 0.
not sub. I should have used a sub is down here. I should a sub 0 down here. Sub is down. Right, x sub 1. And that's just because this is a polynomial function. Right? And so they try to give you this formula that kind of matches this, where the degrees go down, you usually end with a constant. So that's what this means. Don't freak out by it. It's just kind of a math definition of a polynomial function. Really important to know that a is a real number, so we don't have imaginary numbers when we write polynomials, and n is an integer. An integer does not include fractions, it does not include decimals, it does not include square roots, so your powers can only be whole numbers, which includes negative numbers. And the leading coefficient is a sub n, or whatever is with the highest degree is the leading coefficient. Part of your homework today is just giving you polynomial functions, well, asking you, is it a polynomial function, and then asking you for the degree and the leading coefficient, because if you remember from Algebra 2, we can tell a lot about a function based on the degree and the leading coefficient, about which way the arrows are going to go up or down or opposite. We can tell how many solutions it's going to have, and so that's why it's important to know this stuff so that when we get into graphing these, that we know how to do it, okay? Planning for a Monday morning.
We have broccoli and cauliflower today. Just too much.
I'll check it out. Too many vegetables. What if they're mixed together, broccoli and cauliflower?
See, broccoli and cauliflower are like, it's like cauliflower is like white broccoli.
Broccoli, cauliflower, fruit and milk, ravioli and Bosco.
Why can't I have to specify the vegetables? Sort of like apples.
They never tell you what the fruit is.
Yeah.
Sometimes at my son at the elementary, sometimes their fruit is just apple juice, which I don't think counts as a fruit. But because he'd be like, we just had juice today. I know the juice is bad for you. Too sugary. All right, so this is the first part of your homework. Determine if the function is a polynomial function. If so, state the degree and the leading coefficient. As long as nothing crazy is going on, as long as we don't have x's in the denominator, or fractional exponents, or radicals, it should be a polynomial function, which means this is a polynomial function. It's actually just a linear function. What would the degree of this polynomial be? The degree is the highest exponent. So the degree on this one is 1, and you can just say d is 1. I'm okay with that. And the leading coefficient, I'm just going to call LC here. The leading coefficient is the number in front of the highest exponent. So it's not just the first number, it's not the biggest number, it's whatever number is in front of the highest degree, which in this case would be 2. On Chapter 2 test, there are questions like this, so the hard part is you have to remember all the way to there, right? Sure. This is just a number. Is it a polynomial function? You want to say no, right? Because there's no x in it. 1. What if I wrote it like this? You're right. It is a monomial. It's one of those things. Like a square is a rectangle, but all rectangles are not squares. Remember that from geometry? Like polynomials include monomials, right? The definition of a polynomial is a monomial or the sum of monomials. So it's like all monomials are polynomials, but not all polynomials are monomials. That's too much math to speak.
We'll just say yes.
Can I say that? Is that the same as 13?
Yes.
We don't ever write x to the 0 because if there's x to the 0, that's just 1. And it is a monomial, you're right. But polynomials include monomials. I mean, he's just sinking lower and lower his chair because I'm just defeating him with too much math talk today. So, since I wrote it like this, what would we say the degree of this is?
0.
The degree is 0 because there is no
Does that mean the leading coefficient is 0 too?
I think that we should say there, like, when I first did this, I said not applicable, not 0, because there's not a 0 there. But,
Plus 0x.
but the leading coefficient, what is the number in front of the highest exponent? That's just a silly one. Am I going to give you that on the test? No, but I just want to tell you, a monomial is a specific type of polynomial. Just like a binomial, we talk about those, like x plus 3 is a binomial, that's still a polynomial. It's just a polynomial with only 2 terms. Trinomial is also a polynomial. Polynomial includes all of them. It's kind of like real numbers we can break up into integers and rational and irrational, but they're all real numbers. These are all polynomials.
But you just say 13 plus 0x and then 0.
I know, I agree. It's dumb.
No, that one's not.
Ah, yes. What I really want you to know is what's not a polynomial. This is not a polynomial. If you have an x in the denominator, a negative exponent, an x under the radical, this is not a polynomial. Or you can just say no.
No.
If it says y is it not a polynomial, there's an x in the denominator. Or you could rewrite that as x to the negative 1, right? That's also not a polynomial because you can't have a negative exponent. Right? That's a rational function. That's not so bad, right? Oh, look, we were supposed to use clickers on this.
What?
We're going to use clickers and
Yeah.
cool check for understanding
Let's
people.
do it.
Supposed to be a good, effective teacher, but how is this effective when I have to waste time handing clickers? Which is what I love.
I love clickers.
Why didn't we snacks?
Oh my gosh.
Yeah, why don't you give us snacks? You had a good idea when you
Okay, so they're my son's snacks because every day after school he's starving because he just eats broccoli and cauliflower for lunch and fruit.
Why not ravioli and Bosco sticks?
Okay, he eats that too. And, I don't know, like a
There's
cheese
red
stick.
with cheese in it.
And they don't let you just eat those, and it makes me really mad because they should know that people want them, so they need to cook enough for people to keep them. If I'm gonna buy it, they should want to have it.
Oh, it's already started. I don't even
That
know.
was really good. I appreciate it.
But they want you to eat a
Very,
variety.
very
Oh no, I wonder if the answer's already here.
I bring my lunch, I just want breakfast.
Don't look. I'm not prepared. I'm gonna hide it so you don't see the answer.
I can still see.
I know, I never get this remote. I never know where to point this remote.
Oh,
Oh, there we go.
there's a sensor on the bottom of the projector. Oh.
Listen.
Alright.
Okay, okay, we're good to go. Now I can put it back up here.
I feel like I'm losing it all.
You have to turn this on and you have to join my class, which should say join Dixon, and then it should say number 1, ready for you to buzz in. It's just gonna be so fast for me to pass all these out.
Wait a second.
I wish there was like,
Maybe you should
I
have
wish there was like a Velcro thing, like I could just Velcro this under this. Wouldn't that be genius?
You probably could do that.
I know, but then what if people stole them? You think kids would steal these?
No, why would you want to have one of these?
Because kids are bad.
What would you do if it's not available?
So now find a class and now search for Dixon and then it will find it. Because that's how exciting
You
it is.
shouldn't put them at a door and you have to grab one with each minute.
Yeah, I should. But it's Monday and I forgot that I wanted to do
Or you could just waste so much time handing it out.
I could. That's my goal today. How much time can I waste? Yes.
Watch it.
further. Stop. See, this is why I hate clickers, Grady.
We're just plotting over here. Don't
Do you know what else? I used to have people log in because I could give you your own login, so then I could like grade you. Like we could have like a quiz where you just click a clicker, or I could just make your bell work. You don't do bell work, but if I did do bell work, and then everyone has their own login, which I used to put up here. And then rotten children, you say they won't steal them, but they like to log in as someone else's login, so then they can't log in.
That would be a good idea.
I think we should use clear more often. I like them.
What do you still?
They're enjoyable.
Marker boards would be much faster.
Marker boards would be fun too.
Because those make my
Yeah, what happened to your marker board?
Make it.
They used to be under your desk though.
I know, and then people just kick them off, and then at the end of the day, I have to go around and pick up all the marker boards.
Velcro, worth it. I miss.
Things you just hang off of.
I know, I really need to invest in some Velcro if I'm gonna use these. Some really cool things we could use if we all had like devices, you know, like iPads or something that you could use that would be much more efficient than clickers. That you can
Then we all have
just go to a
iPhones.
website. I know, but we
You
don't.
could put on Velcro them on top of the desk. That way, if someone stole it, you go tell.
16 of 19 students have answered.
Guys, it's
Very
good,
good.
guys. Megan, you to answer.
18. There's only 18 of you.
Well, is yours logged in?
No, I turned it off.
Maddie, where's Maddie?
I need to take her test. Oh, 18 of 19, we're gonna stop it. What's the answer?
3.
Oh my goodness, I don't think I can take the answer, but how come it didn't show which letter people picked? If I didn't pick one?
88% probably 3.
Yeah, that's right. This is not a polynomial because it has x as its denominator. This is not a polynomial because it has negative exponent. This is not a polynomial because it's square rooted. And if I would have picked an answer, let's see. Until it's Monday. Properties, answer key. Oh look, I put it in opinion. It's not opinion. Yes. The answer is not 0.
If it's
It's an integer. Oh my gosh, I'm so confused. Never mind.
Just put 3. Because it's a friend.
No, it's failure. Failed. That's what that
failure, fail.
Failed. Alright, there's another one later, I think. We'll see. So just hold on to these clickers. Ooh.
I know this one.
How about this? You've been doing this for years, but we just forget what it is sometimes. I really do have some Velcro around here. Velcro tape.
Save your shoes.
One of these messy drawers.
You should put it like right here.
Right there.
No, I'm just afraid people will steal it. I know that I shouldn't have to worry about people stealing it, but kids like to do things just to be neat.
Yeah, just hanging on a bar.
Like, haha, look what
But I
I
don't like it right there. That's in like in my room. That's
No, I was thinking like under the desk, like so that you don't even really notice it. Like just you know, you can reach under your desk.
with if that Velcro could be that sticky, they're gonna hold outside that.
Velcro stairs for a while. Notice this says linear function. We should know the form of an equation for a linear function, right?
Someone threw Olivia's number 2.
We also have point slope form. Most people don't use point slope form. I like point slope form. Right, both of these would work, right? A linear equation, it doesn't say it has to be in slope-intercept form. But they give you 2 points here. Remember that instead of writing them as ordered pairs, this is like saying x is -1 and y is 2, and when x is 2, y is 3. That's one reason why we use function notation, is we can write ordered pairs like that. So if I'm going to write a linear function, what do I need to do first? Slope. And remember that slope is rise over run, or subtract the y's on top, x's on the bottom. This good old-fashioned fun we're having today. Watch your negative signs when you're finding slope. If I subtract the y's, like 3 minus 2 over the x's, which would be 2 minus -1, which would be a slope of 1/3, I think.
Wait, you can just move it so you don't want to keep a negative and just move some order.
Yes, as long as you go in the same direction, right? If you start with this y and subtract 2, then that means you have to start with this x. But you would have got the same answer if you went the other way. Like if you would have went 2 minus 3 and negative 1 minus 2, they would have both been negative, which would have simplified to be positive. So as long as you go in the same direction, it doesn't matter which way you go. Now you have options. I feel like in Algebra 1, you tend to go with y equals mx plus b because that's the way we like to graph it. It's easier to graph that way, and I'm okay with that. If you wanted to use y equals mx plus b, you have to plug in one of those points in for x and y and solve for b. So, I don't know. Let's just pick this one. If I plug 3 in here and 1/3 times x, which is 2, that's just a little equation to solve for b. I'm a big fan of point slope form because it doesn't say you have to put it in slope intercept form, which means in point slope form, all you have to do is plug in the slope and plug in a point, and I'll show you in a minute how you don't have to simplify it and worry about messing up maybe. Too bad I'm out of room. But I would get 3 equals 2/3 plus b, and if I subtract 2/3 over there, what is that, 2 1/3 or 7/3? Or 2 1/3? Who's on it?
You just like cell phones.
Like really old cell phones.
Bring it in the arrow.
So you could say your answer is y equals 1/3 x plus 7/3. That is an acceptable answer. If you don't want to solve for b, that's where point slope form is amazing, because you could pick either one of these points. I'll just still pick 2 and 3. And you could say y minus 3 equals 1/3 times x minus 2. And if we simplify that, guess what? It's going to simplify straight to that. But if it just says write an equation, not a slope-intercept form equation, that also would get your points, and that's a whole lot less work, right? Less room for error. So, I don't care which one you use. You guys are probably going to use mx plus b because it's, like, stamped in your brain forever. Hopefully. All right, moving on. Quadratics. We also talk about quadratics today. Up until this point in this class, we pretty much only dealt with the standard form of a quadratic equation, which is ax squared plus bx plus c, because we can do the quadratic formula with that. We have a factor like that. But we also have the vertex form of a quadratic equation, which is called vertex form because you can find the vertex by just looking at that form. You might remember this from conic sections last year when you did conics, the h and the k.
Yeah.
You know, new Algebra 2 standards, conic sections are not even in the new Algebra 2.
So we're just a year behind.
Your head, oh yeah. But conics are in Precal, so now when people learn conics in Precal after you guys, because you didn't do conics, they won't be like reviewing. It'll be brand new. But yeah, they took it out. But they added all this stats and probability stuff in Algebra 2.
I like that stuff better.
We have a whole class for that, don't we?
We do have whole class.
Well.
Okay, so this is vertex form. These all stand for something. The vertex is at h and k. And a, just like a in the transformations that we talked about, a can determine stretch or shrink. But also, if you just look at the sign of the number in front, if a is negative, that will tell you that your parabola is opening down. If a is positive, it will tell you it's opening up. And if it's bigger than 1 or a fraction, it could stretch or shrink it also. But what we're really going to work on today is putting it from standard form to vertex form, and then maybe graphing a little bit. So this is kind of your big form today that you need to know. So you graphed on the test that you took on Friday, and they were kind of already written in this form. We just hadn't really talked about vertex form. So everybody okay with that? I don't know. I might be lying. There might not be an answer to your question.
That's really disappointing. The answers are logged in.
That's right. You can all say logged in, and I can stop it at once, and it'll say end of class and shut it all down for you. Like, I have the power up here. So it says, describe how to transform the graph of f of x equals x squared into the graph of f of x equals 2 times x minus 2 squared plus 3 and sketch the graph. The idea is we've already talked about transformations. You should be able to look at that and automatically tell me that it's moved this way and that way and stretched like this. It's just throwing in the fact that the vertex is really written in the transformations there. So what does this plus 3 out here mean? Up 3? What does this minus 2 on the inside mean?
Right.
So we didn't talk about this, I don't know, I kind of showed you, but we didn't talk about that this is really the vertex. And it is, because normally your vertex is at 0, 0. Well, we've just moved it right 2 and up 3, and so we just kind of moved that vertex. So that's why you can tell the vertex by looking at it. And what does this 2 in the front mean? Stretch, right? Does it? Okay. Stretch by factor of 2. So it's going to be twice as long. Could you still make an XY chart to graph this? Definitely. But the idea is you don't have to make an XY chart because you should know, you don't have to graph this part. You should know that an x squared, right, it should be almost just have it be like, oh, I know x squared looks like this. I'm going to move it right 2 and up 3. Definitely shouldn't need an XY chart for that. But if you're not sure from there, make an XY chart. Pick a point on either side. But normally when we go over 1, we go up 1. We're stretching it by a factor of 2. So now when I go over 1, I'm going to go up 2. If you weren't sure, well, you marked or anything. If you plug 1 in there, you should see that you get 2 plus 3, which is 5. I'm going to erase all these green dots I made. And normally when you go over 2, when you plug 2 into x squared, it goes up 4. We would have to go up 8, which I don't think is going to be on my graph. 1, 2, 3, 4, 5, 6, 7. Oh, so close. So when it's in vertex form, it's pretty quick and easy to graph because you can see the transformations, you can see the vertex, and you don't have to do a lot of work. But what if it's not in vertex form, right? We want to get it in vertex form. So there's a couple graphing ones on your homework, but more of this. Rewrite the equation in vertex form, state the vertex and the axis of symmetry. What's the axis of symmetry of a parabola? Yeah, the line that kind of cuts right through the vertex. So maybe we should write that out. The axis of symmetry is that vertical line, which will always be on the x-coordinate of the vertex, right? So it would be x equals h, because h is the x-coordinate of the vertex. A times x minus h squared plus k. How do I take something that looks like this and change it into something that has a perfect square? Or how do I take something that's not a perfect square and make it a perfect square? Completing the square. No. We have to complete the square to do this, but we're not solving this. So there's a little bit of change on how we complete the square just because we're not setting it equal to 0, so we're not moving stuff to the other side. We want to keep everything over here. So you have to kind of keep that in mind when you're doing this. Normally when we complete the square, we would add 5 to the other side, but we're not going to add 5 because it has to say f of x. So I always just like leave a spot to complete the square, and then I kick that minus 5 out to the end. That help with your k value down there. The rules for completing the square are the same. To complete the square of a quadratic, you have to take half of the middle number and square it. If I take half of 4 and I square it, what number am I putting right here? 4. Normally, when we're solving an equation, if I add 4 here, I add 4 to the other side. Yes? I can't add 4 over there because it's f of x. We have to leave it f of x. So if I add 4 here and I want to undo what I just did, what do I have to do out here? Yeah. Because normally you'd add it over there, but you have to move it backward. If you forget that, put it on the other side and then subtract it back over. So we're working on the same side here. We have to keep it all balanced. So now I can write that as a perfect square, right? If you factor this, it's going to factor into x plus 2, x plus 2. Out here, negative 5 minus 4 is negative 9. What is the vertex of that equation? Okay, remember it's x minus h, so you take the opposite sign in there, and but it's not minus k, so you take the sign out there. The axis of symmetry is always x equals h. It's an equation, not a number, so we would say x equals negative 2. It's like that line that cuts it in half.
I'm sure here's where we had to find that last year.
An easier way? Is that what you said?
No, a harder way. That was like
Negative b over 2a. It's in standard form.
whatever it is.
Cody Warren, do you know who Cody Warren is? He's on my little, he's at Franklin. I think he's a junior this year. He sent me a text randomly the other day that said, hey, my friend and I were bored while we were working, and we made up an equation to solve and graph, and we can't remember how to find the axis of symmetry. Who does that? Who just makes up random equations and solves them? Cody Warren.
I'm bored.
And he's like,
Probably graph it.
let's make up a line. Yeah, let's make up a function and graph it and see if we can find the vertex.
Buddy Warren told me he had come to UPS at one time. That was Robert. How long because I'm sending back to working out of
I like Cody Warren.
More of the story, but
I like him even more now that I know he makes up random math problems and solves them when he's bored at work. So, and he's like, I feel so stupid because he couldn't remember how to do it. I was like, you think you make up a problem, you remember how to do it.
or you just put it in there.
So that one wasn't that bad to do. So how can we make this a little more challenging? Remember that when we complete the square, you can't have a number in front of x squared. When it's equal to 0, we would just divide everything by 2. But we can't do that again because of the f of x. So do you remember what we have to do to get that 2 out of there?
Erase it.
Just leave it out.
Factor.
Factor it out. Dividing it, kind of like the same as factoring, but we can't divide everything. So what if I just take the 2, I'm only going to take it out of the part that I'm completing the square with, because I'm not going to do anything with the 7 but kick it at the end. So that would change to x squared plus 3x, leave a spot to complete the square, and then still kick that plus 7 out. And notice, it kind of looks like a times x minus h squared plus k right now. It's like we just pulled the a value out in front of that. But it's not anything to do with the k. How else have I made this awful? This doesn't really divide in half as nicely as 4 did, right? I'm going to keep it as a fraction. Because we're not actually solving it, if you put it as a decimal, it's okay because it's, half of a number and then you square it, it's not going to be that ugly. But I just work better with fractions because when I take half of 3, I know that's just 3 halves. And when I square that, I know that's just 9 fourths. 2.25, I think, if you're a decimal lover. So here's the other fun part of putting the square. We're trying to keep it balanced. So on the last one, we added 4 here, so we subtracted 4 out here to keep it all balanced. But think about what this really is. It's not just 9 fourths. It's really 9 fourths times 2, because there's that 2 in front times everything. So to keep it balanced out, you have to undo taking this times this, which I always just write it as minus 9 fourths times 2, or if you just want to go ahead and say that that's 18 fourths, or simplify it, then you can. I know, that's good. Good old Mr. McClure did a good job.
Where's that now?
Preaching.
Teacher service.
We could have a lot of those.
EOS. Where's EOS at?
I don't know.
Cuba.
My husband's friends with him on PlayStation thing, so he's always on. Whenever I'm watching Netflix, he's always online.
Of course he is.
I think he's just playing PlayStation. Remember that this always factors into half the middle number, so that would be x plus 3 halves, or 1.5 squared. And be careful on this. Every year I have people that just forget the order of operations, and they subtract this, and then they multiply by 2, which is why maybe you want to multiply it first. But this would be negative 18 fourths, or that is So 7 minus 9 halves would be 5 halves. Or 2.5. I'm okay if you use decimals because they work out nicely. A little bit uglier to deal with, but you know, probably you're going to see one of those in your homework, maybe see one on a test in the future. The vertex here, again, is h and k, so you would have to take negative 3 halves and 5 halves, and the axis of symmetry is negative 3 halves. I bet that's Maddie.
Wait, ask who it is. So what you've been
Can't see anyone. I'm guessing it's Maddie.
She just look out the door and be like, I don't see anybody. Miss Dixon was trying to not let you in, we told her to. So we should just not let her in. We said that was fun. How's that going?
Questions about this?
Yeah, was it easy or no?
I don't.
So you just get
It's okay. I'm sorry. I can make one up.
Yeah, do it. Wow, you lied to us.
I know. I had an exit slip on here. This was like my day of becoming an effective teacher. I was like, was going to make you do a problem to give to me, but I just decided against it. It's okay. Look, I'll stop this. You don't have to do it. Watch. Stop class, and it'll turn it off for you.
End of class.
Told you.
Alright, let us go in the hallway now.
1 through 9 odd, 13 through 18 all, 21 through 42 multiple of 3. How exciting is that? Pay attention to what the directions say. Write your equations, like some of them are just, is it a polynomial? Some of them are writing slope equations, and then there's the completing the square, putting it in vertex form. You do have about 7 minutes to get started. Ask me questions if you have them. Definitely, I think you should get in the habit of checking your answers in the back of the book. I know maybe you have it in the past because you feel like it's cheating, but remember that I don't really grade your homework except for the few that I pick for a homework quiz, and so checking odd answers in the back, it's why I pick multiples of 3, not just because I like to make it count by 3s, but I like multiples of 3 because every other one's odd, but there's the even ones in there too, so you can't just be copying on the back of the book. Don't forget that I'm here in the morning. There were a lot of people that didn't have their homework finished, or some people missed a lot of homework. Remember that I'm here about 7:40 every morning. You're welcome to come in and get extra help. I haven't graded all the tests yet to see how they turn out, but you know, as we go through, especially next semester, doing homework is really important because you can ask, I can give you names of people to ask in the past that didn't do their homework, especially second semester. It kind of catches up with you if you're not practicing these problems. So